of a weird class. What I like to do with my class is I like to ask a lot of questions of my students. So I don't really have a class, but that's okay. So for example, if I was teaching something called like terms are terms that have the same variable. Now, again, you have to imagine that we've already talked about what is a variable and those kinds of things. So a variable is a letter. Just a second, where's my cursor? There it is. A variable is a letter. So do you see, I have written 3x, 2x, y, z, 3q, 0.5x, negative 2y, 40z, negative y, 20q, q, and 22z. So I would ask my students, do you see any like terms? In other words, any terms that have the same variable? So I would hope that a couple of my students would say, yep, I know the answer. And I'd say, yes. And we would go through and I would say, circle the letters that are like terms. I'm just going to change my color. There we go. So I would ask a student, let's imagine 3x. I've circled that in red or in purple. Is there another like term to that 3x? And one of my students would say, yeah, try the 2x. I would agree. I'd say, is there any? I'd say there's at least one more. And someone might say, oh, I see the 0.5x. And I would say, I agree. And then I might circle the y in a different color. And I'd say, anybody see any like terms? So anything there that they see that has also a y. And so hopefully a student would say, yeah, I see a negative 2y. I'd say, is there any more? A negative y. I'd agree. And I would say, anything else? And hopefully my students would say, no, that's it. And then I would say, okay, how about the z? Any like terms with the z? And so hopefully some of my students might say, yep, 40z and 22z. And then I might say, okay, anything left? Yep, there's a bunch of q's. And they are all like terms.
你过来看看这个，让你把 echo 停了。
And these are the q's. Okay, so then I might move on to the next page. And this one says, simplify the following algebraic expressions. In other words, they're asking us to collect like terms. So, and I would try to explain, I would ask a student if they understood what A was. And I would explain that A is the same as having a 1A in front of it, that the 1 is understood, but it's not necessarily necessary to write it. And so if we have 1A plus 1A plus 2A, what would be the answer? It'd be like asking apples. If I have 1 apple plus 1 more apple plus 2 more apples, how many apples do I have? 4 apples. So in this case, we don't say apples, but we say A. And in this case, number 2 example, it says 5B minus 3B plus 6B. That might be easier to do in little groups. So when you have 5B, maybe 5 bananas, minus 3 bananas, how many bananas do you have? You're right, 2 bananas, and plus 6 more bananas. What would that be? 2B plus 6B would be 8B. Okay, so you understand, I would continue with this and I would be going through all of these examples, and I don't want to spend all the time on this, just to show you how this works. And so I can switch to a word problem. Those are also very important. It says, the parking charges, and I would have a student read this question. I don't like to read, I like to have my students participate. The parking charges at a shopping center was $2 for the first hour, and some dollars, it doesn't say how many, every subsequent hour or part thereof. So when I read this question with my students, I would ask, do you understand what it means by part thereof? And so in other words, we would say, okay, hopefully some student might say, I don't know what that means. And then I would say, well, part thereof means like If you go at a parking lot and you only stay for 15 minutes, they count it as an entire hour. You can't pay part of it. You can only pay for the entire hour. So continuing on with the question, Calvin parked his car at the shopping center from 2:30 to 5:10 p.m. How much did he have to pay for parking charges? So then we could draw on this on here. We could say from 2:30, he stayed past 3:30, because that would be the first hour, wouldn't it? What's the next hour? 4:30. And then he stayed till 5:10. Now, that's not a whole hour, is it? From 4:30 to 5:30, it's not an hour. But according to the payment plan, it is an hour. So this was the first hour. This was the second hour. And this was the third hour. So how much did he have to pay for the first hour? Says it on the first sentence. It was $2 for the first hour. That's a cheap parking place. $2. And for the second hour, he had to pay, we don't know how many dollars, just $1. And the third hour, the same price. Even though it wasn't an hour, he had to pay that. So we have to add all of these things up. So what's 2 plus D plus D? Okay. And I would explain, obviously, the 2 doesn't have a D, so it cannot be added to anything else. It does not have any like terms. But what's D plus D? Those are like terms. We can add them together to give 2D. So this is our answer. He had to pay $2 plus 2D. We cannot answer any further because we do not know what that D is. Okay, just looking at my time. All right. How about fractions? Everybody like fractions? I love fractions. Fractions are so much fun. I don't know this, so if people listening know how to add or subtract fractions, but obviously we wouldn't just jump into it, we would be working on it. So you'll have to imagine that I've been working on fractions with my students for a while. So 1/7 plus 1/2. Can you add that the way it is? How about this? Let me ask you a question first. Can you add 1/7 plus 2/7? Yes, you can. Why can you add those? That's right. 3 over what? 3/7. And you can add them because they have like. Pardon me? Now, for this question, number 1 here, it's a 1/7 and a 1/2. You can't add them that way. You have to change them so that they have the same denominator, and the denominator is the number on the bottom. So what number is common between 7 and 2? So I would multiply, and again, you might not know how to do this yet, but we would be working our way up to it. So I would multiply 1/7 by 2/2. And I would multiply 1/2 by 7/7. So these are 2 separate things. So I would get from this, I would get 2/14. And then I'd multiply 1/2 by 7/7, which would be 7/14. Now, what do you notice now about the denominators? They're both 14. So what's 2/14 plus 7/14? That's 9/14. All right, so I would do that question, and I'm going to look for one that is a little bit easier for the next one. Let's see. Those are a little hard. Okay. Let's go for this page. More of the fractions. So that first one, number 3, can we add that one as they are? Can we add 6 over 7 plus 2 over 7? Yes, we can. Why? Because they have like denominators. So the answer is 8 over 7. Can we add number 4?
We can't.
We can't because they're not the same.
We can make it into a mixed number.
Yes, we can. Well, actually, that wouldn't help that much, would it? It wouldn't. You can't make that one into a mixed number. But we can change them that they both have an 8 on the bottom. Does 4 multiply to 8 quite easily?
Times 2.
Right. So we're going to take the second fraction and we're going to multiply the top by 2 and the bottom by 2. So our first fraction, we're not going to change, which is 3 over 8. And our second fraction, what's this? Says
6.
That's right. I have to just write it better. It's 6. And what's on the bottom?
4. I mean 8.
That's right. 4 times 2 is 8. So now we can add them together and we make it 9 over 8. Right? Look at number 5. What number is common between 5 and 3?
15.
15, exactly. So what are you going to multiply the first fraction by?
By 5.
Yeah,
And the second fraction by 3.
Exactly. But don't say 5 because you're not multiplying it by 5 because that would make it bigger. You're multiplying it by 5 over 5, which is really just 1, isn't it? It's important that we know the difference. We're multiplying it by 5 over 5 and the second one by 3 over 3. So when we multiply the first fraction by 5 over 5, we get 10 over 15. And we multiply the second fraction by 3 over 3, we get 12 over 15. Do we now have like denominators? Is the bottom the same? Yep. So now we can add them together and we get 22 over 15. How's that? Good? Okay. Number 9, let's do number 9. What number is common between 5 and 15? Wouldn't it be 15?
15.
Right. We don't have to change both fractions. Sometimes we only want to change one. So in this case, we only have to change the first fraction.
6 out of 15.
Right. So you're multiplying it by what?
3.
Not just 3. 3 over 3. Do you agree? Because if I said we're multiplying it by 3, that means just the top by 3, right? So we want to say it properly. I'm multiplying it by 3 over 3, which gives me 6 out of 15, as you said before already. You're right on. Plus 8 out of 15. And what does that give us?
14 out of 15.
That's right. And talking about, is this in the lowest possible number? We would talk about all of that stuff.
It is the lowest possible number.
It is the lowest possible number. This is grade 6 stuff, right? Okay, so another page of the grade 6 book, volume. A cube. Can you think of any examples of a cube? Any examples of a cube? Like a dice, a square box, right? So 3 dimensions where all the sides are the same length. Agreed?
A lunchbox.
A lunchbox. Yeah, but most lunchboxes aren't square. Would you agree?
They're prisms.
They're rectangles, right? They're rectangular prisms. So so a square is a special kind of rectangular prism. It's one where all the sides are the same. I'd say for most lunchboxes, I don't think they're the same. Do you? What do you think? But that's the right idea. So a cube or a dice. All right. So when we have, this one says it's 125. And so the question is, how big is each edge? Well, don't you agree that you would have X, this edge, and this edge is an X, and then this edge is an X? So it's 3, it'd be X times an X times an X, which is actually equal to X cubed. Now, if you don't understand this, that's fine. We wouldn't be jumping into this. We would be doing this slowly. And we would say then X cubed is equal to 125. So again, one good thing about Zoom and things like that is one skill that I would be attempting to teach in this is that I would try and show you that we would have to go with the cubic root of 125. And on your calculators, which is a very important skill, I can show students how to, it's a bit dark right now, but I could show students how to use a calculator and where the buttons are and how to use that, because that's a very important skill for high school and for math. Calculators help us do things. So we would do this and I would find the cubic root of 125 is 5. So again, we would go work on this next question. And I would say volume. So again, if we know the volume, so we'd say X cubed, we don't know the edges, is equal to 1,331. So then we would say X is equal to the cubic root of 1,331. And on my calculator, if I can see my calculator, the cubic root of 1,331 is equal to 11. That's what we would be doing. Okay. All right, that is that's my demonstration for the grade 6 book. I hope that's sufficient for you for what you are looking to find out. I can do a few more problems. I have a more problem, but I think you get the idea, right? We're just getting a taste of things, getting to see if what you're interested in. The other demonstration that I'm doing is grade 8 math. And I am doing a series of math contests called the AMC. And we have all the years from 2000 to 2021. And each question, each contest has 25 questions. And I would be working through each of the questions, each of the contests. And I don't know how long a contest would take us. Just a second. So it depends on the students. It depends on where they're at. And there's lots of concepts in here. And I think what I would be doing is I would be ensuring that you have the contest ahead of time. And then I would, yes. And then I would, then we'll work through it together. Just gonna look at that.
Bro.
Mhm.
你听一下，他说他现在在讲 A squared math。
I don't want.
哎，你稍微听一下，反正是一会儿就结束，8点半就结束。
Bro,
Says,
bro.
I picked a bunch of
I'm not
problems
wasting my time on this.
from the AMC and 2000. And so this is the first question. Which of these numbers is less than its reciprocal? Does anybody know what a reciprocal is? Which number is less than its reciprocal? So one thing you have to know is negative numbers, and one thing, and you have to know what a reciprocal is. So reciprocal is a switch. So I don't know if you know this, but if you have a 4, we write a 4, but we really should be writing, or it means 4 over 1, right? It just means 4 over 1. And so a reciprocal is when the bottom and the top switch. So a reciprocal of 4 is 1 over 4. Okay. All right. So just give me a second. I'm going to erase that. All right. Okay. So it says, which of these numbers is less than its reciprocal? So let's do each one. What's the reciprocal of -2? Well, it would be -1/2. What's the reciprocal of -1? Well, that would be over 1, so it wouldn't switch. It would be just -1. What's the reciprocal of 0? This is actually an important one. 0 over 1 becomes a reciprocal of 1 over 0, which is actually not allowed. It doesn't exist. And that's because you cannot divide something by 0.
Is the answer infinity?
Well, it's of these numbers. It's not infinity. It's not. It's 0. It's called undefined. Because think about it. Could you take a piece of paper and rip it up into 100 pieces? Yes. Could you take a piece of paper and rip it into 2 pieces? Yes. Could you take a piece of paper and rip it into no pieces? Well,
That's not possible.
That's right. That's why you cannot divide by 0. So the reciprocal of 0 is, just a second. Where's my pen? There it is 1 over 0, which is not allowed. And we call that undefined. Do you guys read script? Okay, you don't read script. I'll write it in. I know they don't teach script anymore. Undefined.
What is script?
Script is when people write like this. See, I'm writing my name when all the letters are attached. That's called script.
It's cursive in our school.
Oh, cursive.
And we still learn cursive in my school.
Oh, good.
I think we still learn it at my school, but I just graduated from 4th grade. I'm about to go to school at the 13th, so I might learn cursive in the future.
It's very handy. Some schools teach it, some schools don't. It's a lost art. Okay, and what's the reciprocal of 1? 1 over 1? Well, that would be 1. And what's the reciprocal of 2? Well, that would be 1/2. So now the question says, which of these numbers is less than its reciprocal? Then you have to know a number line. Okay, and you have to know that your number line is 0 and 1 and -1 and -2. And we know that this is less. See that I wrote that in script. I couldn't help myself. And this is more. I'll try and write it in normal printing. More. Okay. So comparing 2 and -2. -2 is here. And -1/2 is here. So which one is less? -2. -1 and -1, well, that's the same. This one is undefined, so it doesn't count. 1 and 1 are the same, and 2 is here, and 1/2 is here. So this one is less. So what's the answer? A. All right. Kind of fun. I like math. Okay, I'm just looking for how much time do I have left? I have a good amount of time. I'm just skimming through my questions looking for my favorites. All right, this one. 64 has the property that it is divisible by its units digit. What does that mean? It means that 64 can be divided by 4. Is that correct? Let's check. Oops, that's a very bad line. There we go. Let's fix that. There we go. 4 goes into 6 how many times? Once. 1 times 4 is 4. 6 minus 4 is 2. Bring down the 4. 4 goes into 24 how many times? 6. So the answer is 16. So 64 is divisible by its unit digits. Okay. All right, let's get rid of that. And it says, how many whole numbers between 10 and 50 have this property? So let's go, but we have 10 to 20 to 30. We could just count to 40 to 50. So how many numbers between 10 and 20 have this property? So how many numbers, just a second. Okay, I'm just thinking about, okay, how many numbers have this property? So how many numbers are divisible by 2 between 10 and 20? So is 11 divisible by 2?
No.
Is 12 divisible by 2?
Yes.
Right? Is 13 divisible by 2? Is 14 divisible by 2? Is 15?
Yes.
Okay. Is 15 divisible by 2?
No.
16 divisible by 2? Yes. Is 17? No. 18? Yes. 19? No. 20. 20 is divisible by 2. And so what I would do is I would create is by 4. Okay, so numbers that end, so I would continue doing that for this whole question. I actually don't like the way this is set up. So question for 2, for in between 22, we get 22 is divisible. Okay, I'm sorry, I'm setting this up wrong. So
1 couldn't
I'm-
1 also be correct? 11.
right, I set this up wrong. My apologies. Okay, so it has to be divisible by its units digit. So so is 12 divisible? So the number 12 is the only number that has 2 as its unit digit between 10 and 20, and it is divisible by 2. 22 is the number between 20 and 30, and it is divisible by 2. 32 is divisible by 2, and 42 is divisible by 2. Okay, so 3. So what numbers? So is what ends in 3 between 10 and 20? 13. Is it divisible by 3? No. 23 is the number between 20 and 30. Is it divisible by 3?
No.
No. 33 ends in 3. Is it divisible by 3?
Yes.
Yes. 43, is it divisible by 3?
No.
So 4. 14 is the number between 10 and 20. Is it divisible by 4? No.
No.
24 is divisible by 24, ends in 4. Is it divisible by 4?
Yes.
34, is it divisible by 4?
No.
44.
Yep.
It's divisible by 4. Okay. And I think I'm going to run out of room here. I have to write smaller. 5. So 15. Is it divisible by 5?
Yes.
25.
Yes.
35.
Yes.
45.
Yes.
There we go. 6. 16. Is it divisible by 10 by 6?
No.
26.
No.
36 is divisible by 6, and 46. No. So 7. Is 17 divisible by 7? No. 27 divisible by 7? No. 37 divisible by 7? 47 divisible by 7? Anyway, I won't continue because I've run out of room on this problem, but that's how we would be working through each of these problems. Let's go on to the next one. All right, angles. How many people like geometry? I like geometry. So it says in triangle CAT, we have angle ACT equals angle ATC. So do you know how angles are written? I would be making sure that you understood how angles were written. So it says ACT. So it goes from A, then down to C, and then angle T. So this is angle ACT right here. Okay. So it says that this angle and this angle are the same because it says that ACT equals ATC. These two angles are the same. And that angle CAT equals 36. Okay. So now the question says, if TR bisects, does anybody know what the word bisect means? It means cut in half. And it's asking what CRT is. So it actually wants to know this angle right here. That's what we're trying to find. So, does anybody know how many degrees are in a triangle? Anybody remember?
180.
180. So if A is 180, can you, and we know that C and T are the same, what would I do? I'd take 180 and I would divide, and I would minus 36. What's 180 minus 36? Which is 144.
144.
Perfect. So 144 is C and T together. So since they're the same, what should I do to 144?
Divided by 2.
That's right. What's 144 divided by 2? Is 72. Right? 144 divided by 2. We can do long division to check that out. 2 goes into 14 7 times, leaving a 14. Divide that out, 0, bring down the 4, 2, 72. Okay, so we'll get rid of that. All right, so 72. So I know that this is 72, right? So, and this one is 72. So I'm going to write equals 72 here. Well, this angle, what did happen to this angle? It got what? It got bisected, right? Which means cut in half. What's half of 72? We could do long division again. 2 goes into 72. How do we do long division? 2 goes into 7. How many times? 3. 3 times 2 is 6. Carry the subtract. Carry down the 2. 2 goes into the 12, 6 times. The answer is 36. So now that this angle is 36. So now how can we find out this last angle? What we would do is we would do 180, because this triangle also has 180 degrees, minus 72, minus 36. What's 180 minus 72 minus 36, or 180? Let's add those two together. What's 72 plus 36? Which is 108. So 180 minus 108 is 72. Okay. Now, yeah. All right, let's do another question. This one's interesting. This has powers. So I don't know if you know much about powers, but it says, what is the units digit of 19 to the power 19 plus 99 to the power 99. Now, those are such huge numbers that you can't calculate them and add them. So we have to think. Does anybody know what 9 to the power 1 is? Let me write that better.
9.
That's right. I did it again. The power 1 is 9. What's 9 to the power 2? In other words, 9 times 2. 81. What's 9 to the power 3? Anybody know what 9 times 9 is? 9, sorry, I have to write that a little bit better. 9 to the power 3.
729.
729. That's right. Now, let's do 9 to the, can you times that by 9 again?
Six thousand.
9 times 9 is 81. Carry the 8. 9 times 2 is 18. Plus 8 is 26. 7 times 9 is 63, 64, 65. Okay, there we go. So what do you notice? I'm going to just erase some of this.
If the power is even, then it ends in, then the power units digit is always 1. If
Exactly.
the exponent is odd, then it must end in 9.
Odd has to end in 9. And even has to end in
1.
1. So the first question is 19 to the power 19. So it's odd. So what is its last number?
1.
It's odd.
9.
9. So it's a big number and then ending in 9. And then 999 to the power 99. I have no idea what that number is. It's going to be very large, but its last number is going to be
9.
9. So it's asking what, when I add up all these numbers, what's 9 plus 9?
18.
And carry the 1 to something I don't know. So what's my last digit going to be?
8.
That's right. Very nice. Okay. Now, if this were a class, I wouldn't work it through this quickly. I would have my students think about it more. But again, because we're just doing a demonstration, this one. All right. Consider 2 geoboard quadrilaterals. What's a quadrilateral?
What's a geoboard?
Well, it looks like,
Quadrilateral is a shape that has 4 sides.
that's right. A quadrilateral is a shape that has 4 sides. So the geoboard, this is a board with a bunch of dots, and you can see the quadrilateral. And it says, which of the following statements is true?
What did you say? I didn't hear.
It says, which of the following statements is true?
I'm talking about the explanation of geoboard.
Okay, a geoboard is a bunch of dots on which we create shapes.
Okay.
Okay, so, but we don't know the distance between these shapes, do we? So I'm going to call but they are equal distant. So this distance, I'm going to call A, is the same as maybe this distance. And I'm going to give it a variable of A. Do you agree? And then this one that's longer, we can talk about Pythagorean theorem possibly here, or we can talk about, just say it's B, it's longer. Do you agree? So we don't know the distance, but do you agree that the perimeter of this one is 2A plus 2B? Right? And if we look at the area, what do you notice when I do this? If I cut it in half.
With 1 square.
Correct. The area is a squared. And if we say the length is 1, then it would be 1 unit square. So the area, we're going to say A is 1, is equal to 1. Now we look at this shape. What do you notice about this? So would you agree that this is a B? This is an A. This is a B. And this is a C. So what do you think? So this is A plus 2B plus C. Now, do you agree that looking at the length of this line, that this perimeter is larger? Because it has 1A, it has 2B, that's the same. That's the same as that. I should choose another color to write that. I'm going to undo that. We're just looking at, we're comparing the perimeter. There we go. We know that this is the same. And then the A, 1A is the same. And that A is the same. But the C, would you agree it's longer than another A? So this one has a longer perimeter. Cursive again. Okay, this one has longer perimeter. Let's talk about area. We said the area of this is 1. Is the area of this the same? Now, do you agree that this is half of that? What is the formula for the area of a triangle? It's base times height divided by 2. So do you agree the base of this triangle is still A and the height is still A? So this triangle has the same area as this triangle. Isn't that cool? So the area is also 1. So then which of these statements is true? We'd have to read them all. And I would read this one. They have the same area, but the perimeter, it's E. So we would be going through each piece of this puzzle. And again, if I had a class, I would be doing less talking and the students would be doing more talking. Do we have time for one more? This one's kind of a cute one. Okay. Again, this is a star and a bunch of angles are given. So we know that this angle is 20 degrees because it says angle A is 20 degrees. Angle AFG is equal to angle AGF. So that means that this one and this one are the same. AGF and AFG. These two are the same. Can you remind me how to find out what that angle is?
$180 minus 20 equal to 160. 160 divided by 2 equal to 80. So that these two angles are 80.
Perfect. 180 minus is 160. And 160 divided by 2 is going to give me 80. So we know that this is 80 degrees. And this is 80 degrees. Okay. Anything else we can find out? Well, if this is 80 degrees, do you agree that this opposite angle is also 80 degrees because of our rule of across? That opposite angles are always the same. And again, this is something we would cover, we would talk about these angles being the same. So also, if we know these two angles, I'm going to circle in a different color. These two angles, these two, right, that go like this. And we have this one being 80. If this one's 80, what's this one? What's the angles of a straight line? 180. So what's 180 minus 80?
100.
Is 100. Okay, so this angle we know is 100. All right. And we can find out a few more angles, but we can't find out that many more angles actually. We can find out these 4, and we can find out these 4, but I actually don't think we can find out that many more angles. Like this angle here, and I'm going to point to it with a different color again. Looks like it might be the same as the other angle, which is 80, but we can't be sure, can we? So if we can't be sure, what do we know? Looking at this triangle, I'm going to draw that triangle out here badly, but I'm going to do my best. Pretend that that's it. This one we know was 100 degrees. And this one is B, and this one is D. Let's read the question again, because I don't think I can find B or D. What does the question say? The question says B plus D.
40.
Well, if they're half, but we don't know they're half. What do we know that they are together?
80.
That's right. We know that they're 80.
80.
That they have to be 80. B plus D has to equal 80, but we don't know what proportion, and we can't figure out. There's not enough information in this problem to solve it. Okay. All right. I think that's enough. I can load in lots more questions, but I think that's good. So I'm just going to look at the chat and see if there are any questions. Everybody's just sending messages. That's good. I spelled perimeter wrong. You're right. I did. Thank you. Spelling's not my forte, but that's okay. I try hard and I'm willing to be corrected. I don't mind being corrected. I like being corrected, actually. Okay. And anything else? All right. I don't see